And what we're looking at today is finding the equation of a line when we're only given two sets of coordinates. And neither of these coordinates are on the y-axis, so neither of them tell us the value of c. But we do know that the equation of a line, our general equation of a line, is y equals mx plus c. And in that, we have that m is the gradient. And we've seen that c is the y-intercept. Now, from this, we don't have a graph, so we can't find the y-intercept just from these immediately. But what we can do is calculate the gradient of the line. We've seen how to do that with sets of coordinates. And the gradient of a line, we're going to call m. And that, we know, is the difference in y coordinates over the difference in x coordinates. So let's plug that in. The y coordinates is 7 minus 1. So 7 take away -1. Just be careful, that double negative. And the x coordinates then, we've got 2 and we've got 6. So it's 2 take away 6. Now overall, 7 minus -1 is 8. 2 minus 6 is -4. And that equals -2. So we know the gradient is -2. That means instead of writing m, every time we do this question, we can write -2. And so my next step then is to rewrite, instead of y equals mx, I'm going to write y equals -2x plus c. So we're nearly there. We found our value of m, but we still need to find this value of c. And what we're going to do is we're going to take either of these two coordinates. I'm going to pick the first one, just to start with. So at 2, 7. So the x value here is 2 and the y value is 7. And we're going to fill these in for the x values and y values here. So let's see what happens. So the y value is 7 is equal to -2 times 2, which is -4, plus c. And we find then that c equals 11. So we've now found our value of m, we've found our value of c. We're just going to plug it back into the original equation, y equals mx plus c. That becomes y equals, instead of m, we've -2. The x stays there, and instead of c, we've got 11. So -2x plus 11. And it doesn't matter whether we use the first coordinate or the second coordinate for this. Some people worry about that. But let me show you. If we had used 6 minus 1, when we put those values into y equals -2x plus c, the y value is -1. X is 6, so -2 times x is -12 plus c. And again, when we rearrange that, we get that 11 equals c. We get the same answer here as we did over here. So it doesn't matter which of the coordinates we use. And so our final answer, the equation of the line, based on y equals mx plus c, is y equals -2x plus 11. Just a second way example, same sort of thing. Again, we're going to base it on y equals mx plus c. The first thing I want to do is find what the gradient is. So the gradient m is the difference in y over the difference in x. Our y coordinates, excuse me, are 0 and 3. So I'm going to put 0 minus 3. The x coordinates are -4 and 2. So it's -4 take away 2. 0 minus 3 is -3, -4 minus 2 is -6, and a negative divided by a negative is positive, so and 3 over 6 is 1 over 2, or a half. So the gradient is a half, and so I can rewrite this as y equals, instead of mx, I can write a half x plus c. Now again, we want to take one of these two coordinates and plug them into this equation. That's going to help us find what c is. I'm going to choose 2, 3 here simply because the numbers are both positive, but it doesn't really matter. We saw in the last example you can use either. So just going to write at the side here at 2, 3. And if it helps, you can maybe write x equals 2, y equals 3. But you don't need to, but it's just helps whoever's looking at this to decide what you're doing or see what you're doing. So the y value is 3 is equal to half of the x value, where the x value is 2, so half of that is 1 plus c. And so we can turn that around to find that c equals 2. So we found m is a half and c is 2. So the last thing is to write the equation in line y equals, instead of mx we've got a half x, and instead of plus c we've got plus 2.